So I'm going to talk about DNSSEC non-deployment, something that I've been concerned about, and kind of come with some ideas of what to do about it at this point. Well, I'm going to talk about how we got to be here and what we might, how we might go forward. So a little perspective, I'll start out with this, is that about 1990, there was a researcher who noticed that the DNS had a vulnerability involving cache poisoning, meaning that it was a very gullible protocol. It would believe anything it was told. And as a result, some wheels were set in motion, and from about in the early 90s, there were contracts and work in the IETF to develop DNSSEC. And that's the protocol initially, the basic protocol design happened about mid-90s in the time. In April 1st, 1998, there was a small meeting where the person who sponsored a lot of the work at the US government asked the people at ISC who produced the only name server at the time, Bind, and those of us who were doing the work, how come no one's using it yet? And that started out the entire DNSSEC deployment work for the past 25 years. We did a lot of work there, and after 25 years, look back on this, we haven't gotten very far in deployment. Now, the assumption then was that operators needed to be told the benefits of DNSSEC. They should just want to do this. It's great to have security. It should just be easy to adopt. So 25 years, I've been watching this stuff. I have lots of measurement data on its non-deployment. But I started looking at RPKI, and I noticed that it too seemed to be lacking deployment, at least through for the past couple of years. It's picking up a bit now. So I thought maybe the problem hasn't been the operators all along. Maybe the operators are doing the right thing here by rejecting DNSSEC. Maybe DNSSEC has some flaws that should be addressed, or maybe in future protocols should be written with operators in mind. And so I began looking at this problem. This is what I'm going after these last couple of months. So in this slide deck here, I don't have solutions yet because I don't think I've had enough time to really study the operator side of the problem. The reason why I'm giving the talks is I want to talk to operators and try to dredge out reasons why DNSSEC is not deployed in places or other technologies, what's holding things back. But I have learned quite a bit in the past few months, so I'm going to try to bring some of that up here. Now, I'm starting out with deployment numbers as being my kicker. Deployment numbers isn't the goal. I don't want to see 100%. That's not the point. The point is I want a usable protocol. I want DNSSEC to be useful, to be rolled out there, to be put in play all the time. And with that, deployment numbers come afterwards. Now, and again, as I'm talking about this, I'm in the learning mode right now, still trying to start conversations about how to get out of this. Now, one of the things, the word operator is thrown around a lot, and I have to admit that I have this problem too. I think of operators as being one kind of operator out there, but there are a bunch. The DNS hosting operators, there are TLD operators out there, ISP operators, public DNS operators are out there, even individuals who do this just for themselves or just for a small group or just their company. So I want people to keep in mind that the word operator is a very far-flung meaning in anyone who touches DNS at this point, specifically DNS here, but it's actually wider than that for the internet. Now operators, I've run into some operators who, they are operators first, internet second, where they just run black boxes. They don't need to know what's in the box, they just need to make sure it works. That's a whole science to itself that we have to respect and understand what it is they're driven by. Now, there are some who are experts in the servers they deploy, and that was kind of the problem with DNSSEC. The early operators in DNSSEC deployment were people who knew the protocol inside and out. So what do operators want? They have two rules they go by. One is whatever it is they're running, keep it running, make sure it doesn't go down. Try to make it healthy, keep the capacity up, keep it refreshed. They're also, the second rule is that if it ever breaks, come back fast, as quickly as they can. Mean time to repair is a very important parameter. And those are the two things that operators look at in services or protocols or anything they're running. Now, operators do make changes. I mean, a lot of us have been led to believe that operators, once they roll something out, will never change it, that change is risk. But in operations land, change is necessary. They do tech refreshes. They do look at long-term trends out there. They're not going to stick with the same thing forever. They know that if they do that, it's going to be outmoded at some point. So part of keep it running means long-term maintenance. Now, but there are two things about changes that we have to keep in mind. They have two rules for changes. One, it has to improve things. It either has increased profit, increased revenue, increased service, increased value, whatever word you want to use for that. Or number two, or maybe also number two, decrease cost. So, revenue and cost are the two things that we're looking at here, benefit and cost. Now, operators looking at the service, They're not so much interested in how it's done. They're providing something to the outside. They have their customer, the operator's customer is generally the employer, could be the regulator that's put them into business service. It could be whatever business unit they're part of. The customers they handle are the people out there that rely on their services. So customers here also an operator, they're in two directions, up and down. Now, DNS operators, we're in a field that's actually pretty young. There's only about 25 years of DNS operations. 25 years ago, when the first companies were incorporated to run DNS as a service. It's still an evolving area out there, and this is one reason why probably now is the time we're looking back and saying we want to do something. It's been 25 years of operators' angst, also, which is about the same time DNSSEC has been out there. And so we have a good reason now to look back and say we should take a look at what operators really want. Now, one of the, I've been asked over the years about DNSSEC, why it's so hard to operate. It's built on top of DNS, which is no joyride itself, and you all know that. DNS is an old protocol. It has lots of quirks to it. It's hard to understand. It's simple in some aspects. It gets very complicated quickly, and DNSSEC just amplifies that. So operational reality, the other factor I want to bring up that we often don't recognize is that the big thing about operations is the staff of people they hire to do this. They're going to have people at the terminal who come and go. These people may not stay for many years. They may be there for many years. They have to make training pretty quick. They have to be able to roll over staff pretty quick. So this is going to come down to some of the impacts of what I see later on protocols. The operators also report to service owners or service regulators. That's an important thing. They're going to look to the regulator or the owner of the service more than they're going to look at standards out there. They really want to make sure they make their customers, people that are paying their paychecks, happy. And operators also, they have a wide range of environments they exist in. They have so many different inputs to what they do that it's not just the technology or the protocol that we think is simple. They have to deal with all the regulatory things out there and reasons why they will or will not give up their zone file, for example. That came up yesterday in the talk. So what's going to make a protocol deployable? Well, I'm not exactly sure yet, but I have a few hints. One thing is simplicity. The protocol has got to be simple. We keep churning out protocols which are like Swiss Army knives is one adjective that's been given to me, where they do everything given the right set of configuration parameters. But that's not very helpful when you're in a panic situation. You have to get this thing to be done right. You want a tool that's very simple because you may not have had time to train the operator in the seat at the time things are happening. Clarity is also important. That make sure the situation exists as clear. Don't keep redefining things. We go back sometimes we redefine how records are read. That means you know how long ago was the software involved, how does it interpret the data going back and forth. And one statement that was given to me by an operator that was very interesting was complexity causes centralization. As much as people don't like centralized DNS, centralized services on the internet these days, a lot of times only a few can afford to actually run it correctly anymore because the protocol has gotten quite complex. So right now, these are sound bites, things to keep in mind. I'm not sure how we're going to put this into action, but these are things that I've been running across so far. And by the way, if you hear these things, you think I'm right about them, wrong about them, bring them up either the mic or to me afterwards in the discussions. Like I say, I'm really trying to learn and make sure I get a good, solid compilation of these lessons. So back to DNSSEC, where did it go wrong? DNSSEC, I think the ideals were solid. It wants to secure things correctly. I'm not going to read all the words on the slide. I want to pick up the pace a bit. In the 1990s, we had a good understanding of the protocol. We understood digital signatures. We had a good idea of how to do scalable key distribution. And somehow all this has still gone horribly wrong. So what I looked at, and I want to talk about some time on this talk, is the 1990s network environment. Now, it is a nostalgia trip. But this is what we were solving for when we had DNSSEC on the operating table. I'm going to go through these individually. Host security was weak. That's a big one. Zone administrators ran everything. End-to-end networking was still everywhere. And network abuse was DOS, not DDoS. We hadn't encountered that yet. And then cryptography was just a much different environment back then, how we thought about it. So host security. We had very weak host security. Hosts were knocked over all the time. So because of that, there was a rule against ever having private key material on a host attached to the internet. If you look at the original DNSSEC specifications, we expected someone to sign the zone offline and transfer magically across an air gap to the internet where it would be put on a name server and then spread out. Now, the first impact of that is that all of the answers DNSSEC gave out had to be pre-computed. And this is a term that I didn't realize was true until Daniel Karenberg reminded me last night that NSD had realized this. The NSD pre-computed all the answers when it sent them out. And that was because DNSSEC required that. Now, pre-computing answers is great if you have the answer you want to give out there. It's not so great if for a negative answer. And because of that, we've had NSEC and NSEC 3. Those two things came out directly from the fact that we had to pre-compute answers. Like, you could ask me a question and I don't know what the question is ahead of time, but if I don't have the answer, I have to have a way of proving to you I don't have it. And there's an amount of work to do that's crazy. It's not just a matter of, it's a matter of just putting the answer together. Like, how do we do it? First, we had to prove to you what we had. Here's what I do have. You can see it's not there. That's the zone walking issue right there. We had to arrange things in order. That causes a lot of problems in the name server. We had to put things in a heap of a tree internally instead of a hash table and so on. So what if we had online keys? We can see that commercial providers actually have online keys. They've been working. No one's had a problem with that yet. Tailored to the query responses would give us a new kind of a negative answer that could be much simpler than we have NSEC or NSEC 3. We could also improve the internal storage, kind of hinting at the tree versus hash table data structures. Now, zone administration was something else that was much different then. We assumed that whoever ran the zone ran everything. So we didn't have the notion of multi-signer. We don't have the notion of multiple providers of DNSSEC for a zone. That's had a lot of impact also. One thing I see today is that we're trying to put into DNSSEC the provisioning of DNSSEC. We want keys to go up and down the tree between the parent and child. And we're stuffing that into the DNS protocol because we didn't realize at the time we didn't have things like provisioning protocols coming down the pike. EPP, for example, was not yet invented when this was going on. In fact, Secure Dynamic Update, which I mentioned at the bottom of this slide here, also was defined just about the same time as DNSSEC. We could have probably made use of that for putting keys up and down. These weren't good ideas back then. So what if DNSSEC came after EPP? We might actually have shoved a lot of the complexity of key management into EPP, or made EPP more general than it is today, so that we could go up and down between registrar and registry protocol. It could be used between any two endpoints. End-to-end networking was threatened at the time. At the time, there's a big fear about firewalls. They were just coming online. In fact, we actually had a problem with that in my company where we started signing our responses, then the firewall of our sponsor kicked all of our data out for 2 days and no one knew about it. We went 2 days without hearing from our sponsor until they called us. And then we realized that DNSSEC was being kicked out because of the new thing called a firewall. We weren't worried about response size at the time. None of the engineers that we didn't conceive that would be our problem. The size of response is a big deal. Today, we talk about it all the time. What if we had started on the DNS stream-based protocol? We wouldn't worry about this so much. We designed for things like QUIC and so on. But then again, they didn't exist back then. We also didn't see that DDoS was going to become the big deal. DDoS was actually helped by DNSSEC, or initially the amplification attacks about 10 plus years ago. You ask a small question of the DNS and it comes back this huge whopping amount of data. That helped amplify all the things that are out there. We did not concern ourselves with response size even then until much recently when we did the key rolls. Now, code availability for cryptography has also changed quite a bit over time. When we started DNSSEC, there were no public libraries available. There was SSL EAY. I don't know if anybody remembers that. Eric A. Young, I believe, was a person. He and another person eventually did OpenSSL at the late part of the 90s. We didn't have a standard library to put in there. We had to find whatever libraries were out there. We didn't think that all resolvers and all servers would have the same code for assigning and validation. HSMs did not exist in the DNS world at that time either. We had no concept of what they were. They came later. They weren't even part of the protocol design. They were from operators saying we wanted to have our keys protected. Patents were a big deal at the time. RSA was patent protected. I didn't get access to that code until just about a year before we started going larger scale in DNS distribution with the DNSSEC prototypes. It was enlightening though when it came on because we were aware of multi-protocol situations, but we had no way to test it until late, and we found a lot of code paths had just gotten it wrong. We had to go back and do things. And there were legal restrictions back then too about export, which I will just lay out there. So with cryptography, cryptography is the one area that if we went back there and looked at it, what could we do about it? What if we knew that there were certain protocols that would be widespread? We didn't know that would happen. We thought people would pick protocols for each kind of data depending on what they wanted to do with the data. But what if we knew that operators say pick one and just go with one at a time? We didn't conceive of that in the DNS. We also didn't conceive of the idea that when you roll from one algorithm to the other, that there's some special things have to happen. A lot of the protocol elements are actually silent about algorithm change, because we just didn't really think much about that, the life cycle of the operator. So what if we knew there was a basket of widely known, commonly available algorithms out there? Nowadays, they're talking about that. There's a proposal to make use of that. So things are going that way. So where do we go from here? So this comes back to recognizing that there have been a lot of calls for DNSSEC to be pushed aside because is it worth the money? Is it worth all the effort to do this stuff? So there's been a lot of effort to try to chip away at the issues out there. For example, child-parent provisioning right now, the DNS key, DS key, upload, download. We have the CDS, CDNS key proposals out there. It's in operations in some places, but not very many, frankly. About 5 operators are actually doing it at the TLD level. It hasn't gotten much beyond that. And there's some question, when it was asked to be spread to other places, there were questions about the completeness of the specification. And so we had to go back and what happens if your policy situation? How do you feed back errors into it? Multiple backend operators, that's another big one for major DNS consumers. But they want to have more than one provider of services because they don't want to depend on any one. The DNS protocol now has so many rules saying everything's going to be coherent across everything that makes it hard to have more than one provider at a time. And moreover, it's also hard to change providers because of the same thing. When you change providers, you want to have the old incumbent be there for some amount of time and then bring on the new one and have them running before you switch. So you're going to have multi-provider there. We didn't even see that back then. Switching algorithms, I've mentioned that a couple times. We didn't have any way of dealing with changing the cryptographic algorithm out there. Right now, double signing is the proposal, and that means larger response sizes, things that we didn't anticipate in the original protocol. Now, the last two I threw in here to more recognition of operators. One is we have to figure out how to avoid DNSSEC mistakes. How many times have you heard that someone's rolled out a new DNSSEC deployment, and because the new zone is out there, the old data gets bottled up? Sometimes it's because you reconfigure the entire pipeline, you do a tech refresh in the whole pipeline, and your policies don't match up. It could be software bugs where software starts panicking when it doesn't see the right alignment of things. We don't have tools that let us look at the changes between zone 1 and zone 2. We didn't look at that as part of the things which should be considered as operational help here. And further, recovering from mistakes. The mean time to repair is something that I don't think we're spending much time on. We have negative trust anchors. That's about all we've ever done in that area. There's operators out there really want to be, operators are afraid of rolling out because if they make a mistake, how can they get out of it? That's the number 2. They can't debug or manage the time out because we haven't spent much time on recovery. How do we turn off DNSSEC when it's gone bad? So a couple of different ways to get there. I have some ideas. So first of all, we have to know where there is. I don't have a there in mind right now. I'm looking for help from the operations. I think we really need to hear from the operators as opposed to we, the protocol developers. We need to have some kind of requirements or goals to get there. I had a manager once say, if you don't have requirements, you don't know when to stop working. So when we hit the requirements, we can stop working on this. There is one path, which is tweaking current records, looking at things we have out there right now. And my argument against that is I get concerned is that as we take a record, you change its definition, you have to roll out new software to understand a new definition. Now the operator gets confused because was that record written by an old speaker or a new speaker, and what was their intent? It's not necessarily clear when you change the definition of records out there, even though it's easy to parse it, but the parsing code's out there. It may not be that easy for operators to handle this. Now, creating new records and new code paths are things that we generally say will take forever to roll out. But I don't know that that's any slower than avoid. It's a better way to avoid confusion because it's all brand new. You know what's going on out there. We need a way to get from here to there, though. We need to know how to transition to the future. And DNSSEC doesn't have a real good transition mechanism. In fact, NSEC 3 was added a long time ago through the use of new algorithm numbers in the keys out there. If you remember that bit of history, that was the great algorithm role, the DNSSEC security algorithm role at one point. That's why we had algorithm 5 and 7, I think, are the same cryptography, but they are different meaning for NSEC records. So consideration, The ITF delivers documents describing protocols. These are the RFCs out there. We have to remember that the RFCs are good for software developers. They're not necessarily very helpful to operators. I had one operator say to me that a 70-page RFC is no help to the operations community. They're not going to write the code. They don't need to know the intricate details, but they want to know how to run what's out there. They want to have something which tells them what are the default values, what are the best values out there. In fact, one question I used to get was, which security algorithm should I use? When I talk about this to operator communities, I'll show a pie chart showing which ones are popular, because I don't know which is the best one to use, but I can tell you what other operators do. What this kind of points to is we don't have operational profiles. There's no DNSSEC operational profile. There's a guide to saying, yes, we have the standard specification for the protocol. There's everything over here, but what parameters should you actually stick to? What are the best default values out there? Right now, we rely on our software developers to do that for us by putting default values in what they distribute out to put on their open source software. Perhaps there's a need for the series out there for this, for DNSSEC. And I'll add one thing I didn't have here is that I've realized a while ago that most companies, we have protocol, or we have project managers. They're the folks that put together a project looking at the technologists on one end and everybody else involved that's in the process together. We don't have that in the internet. We don't have a project manager for the internet. There's no one running this thing. That's the way the internet's built. That makes it difficult to coordinate long-term transitions from one to the other.